Hello, Year 12. So far we've looked at differentiating or integrating different expressions to find the displacement, velocity, and acceleration. Now, the reason we can't use our CVAT equations, our equations for constant acceleration, with these is because the acceleration often is not constant. So if we have an expression for the acceleration rather than a constant, we have to use integration and differentiation. But sometimes there are questions like those in exercise 11e where there's a bit of a crossover between our constant acceleration equations and this chapter. So the sort of questions you might see, for instance, would be I have a constant acceleration, so our acceleration is a, which is constant. My initial velocity is u, and my initial displacement is 0. So that's when t equals 0. And I'm told that I need to show, given this information, that s equals ut plus a half at squared. So, and I'm not allowed to just say I know the CVAT equations. I need to show using calculus. So the way I'm going to do that is start with what I know. I know my acceleration is a constant a. Now to get the velocity, I would need to integrate a with respect to time. So that's the velocity at any point in time. So it's going to be at plus a constant. Now I'm going to use these this u equals u, and this is sort of the velocity when t equals 0, isn't it? So you could think of that as v equals 0. V equals u when t equals 0. So I'm going to say the velocity is a constant u when t equals 0. So if t is 0, I have u equals 0 plus c. So my constant must be u, so I could rewrite that as v equals at plus u, or you might recognise it more as v equals u plus at, which is one of our good old CVAT formulae that we're hopefully super familiar with. But we haven't gone far enough. We need to find out what the formula for the displacement is. So to get s, I'm going to integrate u plus at with respect to t. So we'll have ut plus a half at squared plus a constant. And why does this constant disappear? Well, we've already said s equals 0 when t equals 0. So s is 0, which is 0 plus c. So our constant has to be 0. So we're just going to leave that as s equals ut plus a half at squared. Now the other sort of question they seem to ask us in this chapter is I've got a situation where s equals 2t squared minus t cubed is acceleration constant. So to work that out, we need to differentiate. My velocity is going to be ds by dt, which is 4t minus 3t squared. And my acceleration is d2s by dt squared, so 4 minus 6t, and because we've got a t in there, we can say no. not constant. So the only way it would be constant is if we ended up with the acceleration being a constant, not being in terms of t.